So this is CPM Calculus Chapter 2, number 110. So Lena loves limits. Okay. She wants to find a shortcut for limits so she can predict the function's value without graphing. Alright, that would be nice. Use the following limits, here we have A, B, and C, to look for a shortcut and explain to Lena how she can find the limit as x approaches infinity of the ratio p of x over r of x without graphing. Okay? Be careful, the expressions below are slightly different. Alright, and I can see that they're different, right, because this one has cubed here, this one doesn't, has squared, this one has cubed in the numerator, and these both have squared in the numerator, right, and this one has squared in the denominator. So here, the rest of the functions are the same, except for these terms in the numerator and denominator. Okay, so let's go ahead and, well, we want to find a shortcut to look at this without graphing. So to find that shortcut, let's look at the graphs. Okay, so let's plug these in. I already plugged them in, so here's part A is x squared minus 7x plus 6 divided by x cubed plus 9x minus 2. Okay, so let's graph that. And here it is. Let's zoom in so we can see a little closer. Okay, so on the left, it's going like that. On the right, it goes up and like that. Okay, so let's trace because we want to look at F3. We want to trace because we want to look at the value as x goes to infinity. So as x gets larger and larger, what's happening to y? Right, so here y is negative 1.6, negative 1.5, negative 1.3. Okay, so it keeps getting smaller and smaller, or closer to 0. I guess it's negative, so just getting closer to 0. Now let's zoom out, because now I kind of see it closer. I want to see it farther out. If I zoom out, okay, on the left, it's going like that. On the right, can't even see it, but let's trace again. So here, as I get bigger with my x values, my y value, it looks like it's just approaching 0. So I would say, looking at the graph, the limit as x approaches infinity, it keeps going to the right, it equals to 0. Okay? So let's look at all three of these. So let's go back to our graph. I'm going to turn off this one and go down here. And here is part B, x squared minus 7x plus 6 over x squared plus 9x minus 2. Okay, so I want to turn this graph on by putting a check next to it. And I want to graph. Okay. So here, our graph, well, so it looks different. Okay, well, I see as it goes to infinity, I see something happening over here. So that looks like where I want to zoom in on a little bit, or let me just trace. Okay, so as I trace, x is here, y is negative, okay, negative again. So if I go to the right, I keep getting, well, so now I'm getting above 0, right? So I'm going to 3 point something, was increasing forever. Well, let me zoom out to see if I can see anything to the right more. Well, zooming out makes it just hard to see anything, but let's continue to trace. Okay, so I see y going, okay, y is definitely growing. So how big is y going to get? I don't know yet. I could keep going. Well, let me make this easier. I'm going to change my window to start, instead of starting at x is negative 0.09 and going to 80. Let me just start at 80 and go to, I don't know, 150. So I'm looking all the way with the range of x to the right more. And then let me graph that. So I don't see anything. So I know that the graph is like somewhere close to our x-axis. So let me change the y scale to go from, I don't know, -1 to 2. And graph it again. Okay. Okay, so remember, this is -1, 0, 1, 2, and this is between 80 and 120. So let me trace now. So at 100, x is 115, y is 0.87. Okay, so it keeps getting bigger and bigger. Well, let me plug in a value. So if my x value is, I don't know, 250, what's my y value going to be? Oh, it's not within the window, so let me change the window to go from, I don't know, 250 to 300. Okay, and graph again. Okay, so now it looks like a line. So let's now see what the value is in trace. Okay, so now y is just 0.945 as x keeps getting bigger. Well, y is still growing. Well, let me even try a bigger number. So I'm going to change, so let's try, I don't know, 1,000 to 1,050. Okay, and graph that. Okay, so it's still within my window, so it's still between -1 and 2 in the y value, but now I'm at 1,000 starting at, so let me trace. Oops, I didn't need to push that F3. Okay, so it looks like my y is just getting closer and closer. It's increasing, but it's just getting closer and closer to 1, right? It's 0.98, so it's getting closer and closer to 1. So as x goes to infinity, I'm going to say it's equal to 1. Okay. So finally, let's look at part C, the graph. Okay, so I have y equals. So I want to turn off the graph in part B and just look at graph in part C. So that's x cubed and x squared in the denominator. So let's graph that. Okay. And now I don't see anything in my window, right? Because I remember I'm between -1 and 2, and like at x is 1,000. So let me go ahead and let's just change it to zoom standard and see like what it looks like now. Okay, so so it looks like my y value is increasing here, right? As I go to the right, the y value is going up. Okay, so I think that, so it's increasing, then as x goes to infinity to the right, my y value is going up, up, up. So I'm going to say that limit is equal to infinity. And remember that that infinity means limit does not exist. So no limit, right, exists. So just remember that at infinity, no limit exists, but it equals to infinity. Okay, so now that we've done this graphically, can we find a rule to piece this together so we don't need to graph it? So what changes here? Again, just the exponents, right? So I guess, so the only thing is like 2 on the top, 3 on the bottom, 2 on top and 2 on the bottom, 3 on top, 2 on the bottom. Well, okay, I kind of know the rule already, so it's going to be hard for me to just kind of guess it, but I can see that these are the same, right? The powers are the same, so these kind of cancel each other out, and we have 1. Okay. These are different. Well, the one on top in the numerator is smaller than the one in the denominator. The one I'm talking about, the biggest power in the numerator, is smaller than the biggest power in the denominator. So as x goes to infinity, okay, this one gets bigger, bigger, faster. So you get a number over a larger number becomes 0. Okay. And likewise, as x approaches infinity here, yeah, I could think about it like that. These cancel each other out, right? And it becomes 1. Here, the numerator number in the power is bigger, and this one's smaller. So as x approaches infinity, Okay, so the numerator gets bigger faster, and so that's going to approach infinity. Okay, so now I can just say, well, what's my tool? So here we have, if we have the limit as x approaches infinity of p of x over r of x. So here we have, if in the numerator p of x, the power of p of x, if it's less than the power of r of x, right, the one in the denominator, then our limit approaches as x goes to infinity of our ratio p of x over r of x, this p, equals 0. Okay, so if the power of p of x in part b equals the power of r of x, then the limit as x approaches to infinity of the ratio p of x over r of x equals to 1. Okay, and finally, if the power of p of x, right, 3 in the top, is greater than the power of r of x, then that means the limit as x goes to infinity of p of x over r of x equals to infinity. Okay, so this is the kind of general shortcut we could tell Lena. In reality, we're looking more than just at the powers, but the coefficients. Okay, so the coefficient in front of the biggest power, here they're all 1, right? We have an implicit 1 there. So for this one, it doesn't matter. So it's 0 because the power in the numerator is smaller. So it's going to become 0 when we look at the limit going to infinity. Except this one changes because we're looking at these terms cancel out. So we're only looking at the coefficients and that ratio. So if it was 2x squared over 5x squared as the biggest terms, well then the limit would go to 2 over 5. Okay. And over here, we're looking at the biggest power over a bigger power over this smaller power. And again, we're looking at the ratio, yes, but also we're checking if this was a negative or this was a negative, right? If one of these was negative, then it would approach negative infinity because the negative divided by positive would make it negative, or positive divided by negative would make it negative. If they were both negative, it would still be positive. So keep that in mind. The coefficients, like plus or minus here, can matter, and change it to plus or minus infinity. The coefficients, if the powers in the numerator and the denominator are the same, they matter because the limit equals that ratio. And here it doesn't matter if it's smaller in the numerator and bigger in the denominator, we're always going to be approaching 0. So this ends CPM Calculus Chapter 2, number 110.